Saka, and I'll be presenting my work on the customization of a reconfigurable assembly fixture for small, medium, and micro enterprises in jig manufacturing. So this is my presentation outline. I'll be going through the introduction, final statement. Okay, perfect. Yeah. Okay. So, for the past couple of years, we've had a lot of changes in the manufacturing system, and most of the system end up with having more costs. Companies are trying to make sure that they decrease their cost as much as possible, and one of the key things that they have there is equipment. Capital expenditure is still one of their biggest costs when it comes to initial product. So, the growth of SMMEs has been in question for a long time, and with COVID, we really need to up our games in SMMEs, as SMMEs contribute over 36% of the country's GDP. Okay, so problem statement, right? So, a couple of years ago, we partnered up with Gibela to produce the welding jigs. So with the welding jigs, what happened is that we're producing parts. There were parts coming in from Brazil, and then from Brazil they came to South Africa. And because Gibela have a mandate as well to achieve their 65% and above local content, so we had to develop the jigs. Once the jigs were developed, we wanted to move forward to say that, but how can we produce these jigs fast in South Africa, as well as the maintainability of them? Right. So the aim of the study is to customize the RAF to assemble customized jigs in the rail car manufacturing industry. But this application is not only limited to rail car manufacturing, but it also can move to automotive as well. Right, so to achieve this goal, we need to identify some few things. First things first, we need to identify and classify the different operations that we can do on the RAF machine, develop a framework for the jigs, as well as at the end develop a cap system so that we can customize the jigs in any way possible. Right. Like I said, this is the last few slides are going to be my worst slides ever, but yeah, there's some technical problems. So this was the framework this was the methodology for the study. So in this framework, it was more on desk research, as well as the observation of the RAF itself on what it can actually do. So we do have a prototype ready. If you'd like, you can come to the Zilla, we'll demonstrate it for you. So the methodology, like I've mentioned, it was more, it was qualitative. I've approached more into desk research and interactive studies. So in this case, right, so in this case, just observing the machine and see what it does, and then also observe some of its capabilities. Right, so with the methodology that we followed when we were sorting out the jigs, well said, let's assess the type of jigs that we have. The jigs were classified into two. We had swiveling and non-swiveling jigs, and also they were sorted out by sizes, depending on how big they are, so that we can be able to classify them perfectly for the RAF machine. The second step was to assess the assembly process of the jig, look at how the jigs are being assembled, in this case, so that we can actually customize the machine based on that. And then lastly is to assess the size that I've mentioned. Right, so this was the methodology that was used for the jigs when they were being developed. The key step there was to have to know if it's feasible or not to produce the jigs. Once the feasibility was done, we moved on to negotiate the prices, and then we started identified the correct supplier, which was an SMME, and then we were able to produce and deliver the jigs. Right, so this is the framework. It's not a very big framework like the fancy stuff that we've seen lately, but the frameworks that I've decided was, let's get the general specification of the jigs. Let's find out the jigs or the material that we want. What is the specification that the customer wants? After that, we say, okay, so are the specifications feasible or infeasible? After that, when we look at the feasibility, we're not just looking at the feasibility based on just from our side to say that can our machine do it. We look at the feasibility based also on what the supplier actually have in hand. So if a supplier want to have the jig in a different powering system, for example, the three major powering system, which is pneumatic, electric, and hydraulic. We can't produce a jig, the ref machine for a SMME that cannot work with hydraulics, for example. So we have to make sure that the jig is customized perfectly for that specific customer. Okay, and then we look at the powering system, we look at the sizes, and then at the end of the day, we say that we're producing a ref machine that is perfect for the SMME. The one thing about the ref machine that, unfortunately, the slides were messed up a bit, but it's fine. One thing about it is that we can customize it based on its size. So if you want the ref machine to be big for your specific application, we can just change the schematic, put in the proper powering system, and then everyone can be able to use this particular machine. Right, so in terms of the cap, when we look at the cap, we say, okay, so here's the cap framework that we had. First things first, import the model, have the geometric creation and fabrication based on what the customer needs. So even if they're not producing the jigs for real color manufacturing, these jigs are still being able to be produced for that specific industry. And then lastly, we have the results. Once we have the results based on the geometric creation and fabrication, then we are going to be able to fabricate the jigs for that specific customer. So this thing is customer orientated rather than being generic. It's a pity that Prof. Muchi is not here to hear this as well. Right. So in conclusion, different operations for the REF were identified. We did develop, like I said, there's some stuff missing, but the development of the jigs that were linked to the REF was identified as well, and then a framework for the CAEP was identified, as well as ultimately the customization framework for the REF. Okay, so in future work, we want to automate the machine. We want to create the supply chain for the REF in terms of the market, as well as we want to do some more research on different powering systems. The current prototype that we have, it's only powered by the current powering system. It's only powered by the pneumatic system. Yes. So what else? So at the end of the day, we want to develop SMMEs. So it's not just about putting research on the carpet and then there it goes. We want to make sure that it goes to the SMMEs. If SMMEs do not have the skills that are needed to maneuver with this machine, we are able to say, okay, SMME, you don't have this. Can you please work on this skill so that you can be able to operate? One of the outcomes as well from this was a spin-off company. Item number 7. I think I was with Professor during lunch. He said that, Charles, what do you live for? You know, it was a joke about it. I was sitting with some of the guys. Item number 7 is based on what I was saying. That was item number 7 based on an agenda, as well as yeah. I think that's it. I'd like to thank you, Bella. YouTube as well as